All right, here we go. As promised, these are the 3.3 notes that I will not be here to teach you guys on Thursday, so sorry about that. All right, let's see here. First blank is a rotation. A rotation, give my handwriting, it's always hard on a screen. All right, a rotation, and we're going to notate that as a lowercase r. So keep in mind, a capital R was a reflection. So a lowercase r is a rotation. So what this kind of notation means is we are going to rotate. We are going to rotate, a geometric figure. Maybe it's a triangle. I'm going to say we're going to rotate triangle ABC. All right, I'm just making something up. Rotate triangle ABC X degrees. All right. Rotate triangle ABC X degrees. That's why you have the little degree symbol there. About, or I'm going to say around point P. All right. So for all the ones that we're going to talk about in these notes, point P is going to be the origin. All right. So another name for a rotation, we can just kind of think of it as a spin. All right. This can be a transformation that rotates each point. Let's see here in the pre-image about point P. All right. And again, point P, that's our origin in this case, called the center of rotation by an angle of X degrees. Now, we can rotate it any degree that we want. Maybe this is a 30-degree angle. All right. So what we do is we measure the distance from that point we're rotating about to point A. Right? And then what we do is we hit a protractor and we're going to measure a 20-degree angle, 30-degree angle, whatever that angle is. And we have to measure the same distance away. So that is where A prime ends up. All right. We do that for each one of our points. So point C, you would measure the distance from P to C, and then you would rotate it, the 30 degrees or whatever we have. And then you have to draw it the same distance away to get to C prime. And last but not least, you're going to do that with B. So measure the distance between P and B, rotate it that direction, the 20 or 30 degrees, and then draw the line right there to get B prime. All right. Now, fortunately, rotation is motion, so lengthen the angle, measure preserved. Note that a rotation is, all right, this is one of my least favorite things about all of math. A rotation is counterclockwise. We might have to start picking a different word soon because you guys might not know what counterclockwise is, right? For a positive angle measure. So what I mean by that is think of a clock. So an analog clock. So you got a 12, you got a 6, a 3, a 9, fill in everything else. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. All right. So a clock. Maybe we are at 3. I don't know. Or how about this? All right. We're at 3:15. All right. So counterclockwise is the positive direction. Counterclockwise is the opposite direction the clock spins. All right. So if I'm looking at a graph, if I measure an angle, right, counterclockwise direction, this angle here would be 120 degrees, a positive 120 degrees. If I talk about a negative angle, which they do exist, but in this class we kind of pretend that they don't exist, clockwise would be a negative angle. So this would be like a negative 60-degree angle. And then the red one would be a positive 120-degree angle. All right, so counterclockwise angles, positive. All right, so luckily we have some rules for all of these, which does make life easier. So before I kind of just tell you what the rules are, let's see if we can kind of figure out what they are. If I look at this point right here, this is point A. All right, so let's think about that as an ordered pair. Point A, I don't know why I put a prime there. Point A, that is just at the location 2, 4. Now, if I take point A and I rotate it, all right, so we're talking about rotation. So I'm going to spin this 90 degrees. 90 degrees is a quarter of a turn. All right, so I'm going to spin this quarter of a turn. All right, let's figure out where that ends up. All right, I'm going to call this A prime. So A prime, after a 90-degree rotation, if we think about that, we are at -4, 2. All right, so I'm going to write that order pair down, -4, 2. All right. I'm going to spin it again. So that was actually here. Let's say this was a 0-degree turn. This was a 90-degree turn. All right, let's look at a 180-degree turn. Right, so if we kind of put this back in the original spot right here, 180 degrees, that's half of the spin. All right, so here's 90, here's 120. All right, I'm going to call that a double prime. All right, so a double prime now is at -2, -4. All right. Going down the line, the next one in the 90-degree sequence is a 270 degree. All right, this one is quadruple or triple prime rather. All right, so I'm going to spin it 90 more degrees, and that is going to land us right here at a triple prime. All right, which puts us at, let's see, 4, -2. And if we wanted to go one more, if we add 90 more degrees to this, it gets us right back to the start. That is a 360-degree angle, right? Which you could call a quadruple prime if you want to, which puts us at 2, 4. All right, which 360 degrees is a full spin. So the first one and the last one, the original point, the last one, should be the same ordered pair, which they are. All right, so maybe you notice a pattern here. We are looking at, we got, originally we were at 2, 4, then we're at -4, 2, then we're at -2, -4, then we're at 4, -2. Basically, what we're doing is to go from one to the other, we are flipping the order, right? So this guy is X, Y. All right, we're just going to switch the order around. This one is -Y, X. All right, so you switch the order, and you're going to make the one in the very front negative. All right, so if we do it again, I'm going to switch the order. So we have an X and a -Y. And I'm going to make the one in the very front a negative, and so on and so forth. Switch the order. So we have -Y, -X, and then make the one in the front negative. Now keep in mind, -Y makes it a positive. All right. And then last but not least, switch the order and make the front one negative. So negative is another positive, which gets us back to that X, Y. All right. So these things right here, I'm running out of colors, are the rules for a 90-degree turn, a 180-degree turn, and a 270-degree turn. All right, so I'm going to go ahead and write all of those down. A 90-degree rotation, we said, is -Y, X. A 180-degree rotation is -X, -Y. Right? And the very last one at 270 is +Y, -X. Right? And there we have it. So that's really all we need to know to kind of be successful in this section here. All right. So 2 ways to think about this. Triangle CLT. Let's just go ahead. I'm going to write down all those points right now. We're at 4, 1. All right. L is at, what is that? 3, -3, it looks like. All right. And then T, I'm going to say 5, -4. All right. So we are rotating. So this guy right here, this says rotate triangle CLT 90 degrees. And then that O right there, that is the origin. All right, on a graph, on a coordinate plane here, the origin is always the very middle. All right, that is the ordered pair 0, 0. That is what we are spinning this picture about. All right, so since it is a 90-degree angle, the rule for this is xy turns into negative y x. All right, so I'm just going to fill all of that in. So the first one was 4, 1. Now it's negative 1, 4. All right, the second one is positive 3, 3. All right, so that negative, negative cancel out. That's why it's a positive 3. All right, and then we have a positive 4 and a 5. All right, and there we have it. So I'm just going to go ahead and plot those points now. Negative 1, 4 is going to go right here. Negative, let's see, we got 3, 3 is going to go right here. And then 4, 5 is 1, 2, 3, 4, 1, 2, 3, 4, 5 right here. All right, so we have C prime, L prime, and T prime. Right, so connecting those dots, there we have it. All right. And that's all we have to do for this problem. All right, now the next one. Let me show you another way to do these. Maybe you don't like writing down those ordered pairs. So instead, let me show you kind of another option that we have here. So if I look at this graph, let me just resize it a little bit. All right, and we just have to think about, all right, it is a 180-degree spin. So that is half of a turn. Here's what I'm going to do. I'm going to physically spin my piece of paper. Just like that. And now just think about where those ordered pairs are. All right, so think of this, triangle right here. Where would those be on the graph before, we actually spun the whole thing around? If you want to, just go ahead and spin it back. All right, so I'm just going to do that. And maybe write down where those points are. All right, so mine looks like it got a little bit off here, but it would be like that. All right, so there are the points. So if you want to just go ahead and spin it and just think about where those ordered pairs would end up in the first place, you can totally do that. Right? So let's see here. I have H is at 1, 2, 3, 4, negative 4, 5. I have R is at negative 3, 1. And then the last one is at negative 5, 3. All right. So the rule for the 180-degree spin is xy. All right, that turns into negative x, negative y. All right, so you keep the order the same, you just make them both negative. All right. So let's see here. Let's see here. Where's H prime? I should have labeled my points. So this is H prime. This is V prime, and this one was R prime. All right. So if we follow the formula, right, that negative 4, 5 needs to turn into a positive 4, negative 5. Right, which if we look at our picture, H prime is at a positive 4. We're going 4 to the right, and we're going 5 down. All right, so that one works. And so on and so forth. We have a positive 3, negative 1. And then the last one is positive 5, negative 3. Right, which matches up with our ordered pairs when we physically spun the piece of paper around. All right, and that's what rotations are. Now, on the next page, we're not going to do this just because I need a protractor. It'd just be a lot easier to show you in person. So, but again, I did mention this previously on the last page. You could get a protractor out. Let's grab this protractor. And then line it up. So I'd put it like on point T. Right? And then I'm going to measure the distance from point T to point A. So I'm going to have something like this. No, I'm not. Maybe they're not going to let me draw it. All right, that point right there. All right. Measure that distance. Measure a 120-degree angle, which ends up being right here. And then draw that same, struggling here, draw that same distance. All right, so it would look something like that. And here is a prime. All right. So you're going to do that for all three of the points. Measure them. Make sure this is a 120-degree angle. And then connect your dots. All right. So that's how we would measure specific angles. In this class, I think on all your homework, it just has 90, 180s, and 270s on it. All right. Now, the next one we're going to talk about are dilations. Dilations, these are very easy. These are just making pictures bigger or making pictures smaller. All right. So think of this as like a multiplier. Right. You could almost think of it as a scale factor. All right. So the notation on this one. So if I look at this first one, it says dilate 2 about the origin. My notation here, I'm going to say capital D, right? And then the number 2. All right. So that capital D, that little 2 is like how much I'm multiplying it by. And then I'm going to say triangle V W X. All right. So what are we doing with each one of these? All we're doing is you're multiplying the order pairs by 2. All right, so let me just go ahead and plot this one really quickly. So we're at -1, 0. We're at 2, 2. And we're at 1, -2. All right, so here is the original triangle. You have V, you have W, and you have X. All right. Now, if I take -1, 0, all right, and multiply it by 2, right? Just multiply both of those numbers in there by a 2. What are we going to have? We're going to be at -2, 0. All right, so V prime is going to go right here. All right. Similarly, I'm going to look at W. W's original point was 2, 2. If I multiply both of those points, both of those coordinates by 2, we end up at 4, 4. All right, so that is X prime. So maybe I'll put V prime here. I'll put X prime here. And then the last one is W. W is, oh, shoot. Guys, I made a mistake. This should have been W. I got my points flipped. And so that should be a W. That should be an X, which means this point at 4, 4 is W prime. Sorry about that. Put a tally on the board. All right. Let's see here. And the last one, X. We're at 1, -2. Again, multiplying both of those things by 2. We're going to be at 2, -4. And that is X prime. So 2, -4 is right here. And do something like that. All right, so that is what this triangle looks like when we dilate it. All right, now number 2, same exact thing, dilation of 3. Okay, so it's going to be 3 times the size. All right, I'll let you guys do that one. But these next ones, dilation of 5 halves. All right, so that is kind of ugly, but that's okay. So let's just look at it. K prime. I'm going to get point. Actually, no, I'm not. I'm going to plot the points first, and I'm going to be careful to put everything in the right spot. All right, so here's K. Here is, let's see, -2, 1 is going to go right here. That's L. 0, 2 is right here. That's M. And then N is at 2, -1. All right, so we have a 4-sided shape. All right, so a dilation of 5 halves. Now, if you want to think about it in your calculator, 5 halves, that's just 2.5. All right, so you're just multiplying all your coordinates by a 2.5. All right, so K prime 2 times 2.5. Negative 2 times 2.5 is negative 5, 0. All right, L prime is going to be negative 5, comma 2.5. M is going to be at 0, 5. All right, all I'm doing is multiplying these numbers. And N prime is going to be at 5, comma negative, what is that, 2.5? All right, and I'm going to go ahead and plot these points. All right, so let's see here, negative 5, 0. That's going to put us at 1, 2, 3, 4, right here. All right, that is K prime. All right, L prime is at negative 5, 2.5. Now, 2.5, right? It's halfway between 2 and 3. So when you plot your point, just put it halfway between, 2 and 3. That's about the best we can do. What is it, perfectly in there? Maybe it's a little too high. I don't know. So just mark it off as best you can. Here's M prime. And the last one, 5, negative 2.5. Again, that's going to be halfway between negative 2 and negative 3. So just get it close. But connect the dots. And there we have it. That is that shape that looks enlarged. All right, we have increased it by a factor of 2.5. All right, look at this. If I drag all the sides, the angles still match up on this thing. All right, if I look up here, if I drag that over, the angles still match. If I look at this one, the angles are the same. And if I look at M, the angles are also the same. So anytime we dilate something, the angles don't actually change. It's just the side lengths, all right? How long are each sides? How long do those change, right? Not the last one, dilation of 0.5. So this one, we are making smaller, all right? So first things first, plot the points, 1, 2, 3, 4, 1, 2. All right, so here's H. I is at negative 2, 4. J is at 5, 3. And then K is at 0, negative 5. And so that is our picture. Again, some kind of four-sided shape. I don't know what it looks like, but we are dilating at 0.5. So what that means is chop every number in half, okay? So H prime, that's negative 2, negative 1. I prime is negative 1, 2. J prime is 2.5, comma 1.5. And K prime is 0, negative 2.5. All right. And then just plot them. All right, so there's your H prime. I prime is at negative 1, 2 right here. All right. Now, J. If you look at J, that's 2.5, 1.5. So that one, it's not going to be anywhere on a lattice point. So it's kind of right in the middle of a square, but that's okay. All right, that is J prime. All right, it doesn't have to sit on a lattice point exactly. All right, and then the last one right here, that is your, what is that, K prime. And of course, connect the dots. So when we dilated by a factor of a half, it got smaller. And if you look, all the angles, if I kind of drag this thing over, all the angles match up. All right, so you're not changing any angle measures, you're just changing side lengths. And that's kind of something we'll talk about in Unit 6, actually. All right, so one thing I do want to make a note of is when we dilate, I'm going to use capital D, all right? When the dilation is greater than 1, that is an enlargement. All right, so the image gets bigger than the pre-image. All right, if the dilation is less than 1, but bigger than 0. All right, so our scale factors need to be positive. All right, we call this a reduction. All right, and if the scale factor equals 1, then there's no change. All right, it doesn't get bigger, it doesn't get smaller. All right, so that's the last thing I want to talk about there. But there we go. That was sections 3.3 and 3.3.5. All right, so how do I stop sharing my screen? I gotta press that one. Now we can end it. All right, so we'll see you guys later.